Good morning, afternoon, evening. This will be day 3 of our polynomial curves, best fit lines, quadratics, and so forth. We're going to start with linear curves. So my advice, first of all, is maybe you might want to pull out a Chromebook. We're going to use Desmos, Desmos graphing calculator, to do lines of best fit and use technology rather than an old graphing calculator. We're also going to do it by hand as well, but we're going to start with using Desmos. It's a very helpful tool in doing that. So we're going to use a little bit of this Desmos, and of course, I'm going to make some notes as well today on the blackboard. So I'm going to be popping back and forth between the two. So you might want to pause the video at this point and go dig up a Chromebook or something you can get to online with. Okay, so as the Blackboard is opening up, I'm going to just shrink my Desmos down a little bit and get my preview here so I can see myself and know what the time is in terms of how long we are today. So we'll put that over here. And we'll want to also get a background graphing question here that I want to put up. Okay, so let's start off with, let me get that on the other side here. Pardon me for a second. Best fit curves, where are we here? We don't want to do best fit curves. We want to do best fit lines today. And there's my notes on that. Where are you? There they are. Okay, so what are we going to do today? Okay, so let's get this adjusted here a little bit. Okay, so we'll be working on Desmos today. It's our first tool that we're going to use to find best fit lines. And we've all done this in science, okay? In the way that you leave some points above the line and below the line, and you try to find a linear relationship. But data is not always linear in nature. It may be quadratic, it may be cubic. Okay, we studied at the beginning of this quadratics, cubic shape, and linear shapes, and constant shape. So those 4 shapes are the 4 different kinds of curves that we're going to study graphing here, and we're going to use Desmos to help us out. So the first thing that we're going to do on day 3 and unit 4 is we're going to look at, first of all, we're going to look at the standard forms for linear, quadratic, and cubic equations. And we're going to write them in the Desmos notation way so that we don't get confused. Okay, and we're also going to look at using Desmos, which is an online graphing calculator. Now, it's been a while since I used this last year, so I might be a little rusty. To plot some graphs. Okay, and today we're going to be looking at linear ones. Okay, and then tomorrow we'll look at curved ones, which will be the quadratic or cubic ones. I'll have to dig some up, and then we're just going to do some examples. Okay, and I'm going to be switching back and forth. Okay, and we're also going to do, you can do this by hand as well, but I'm going to allow, when you write your exam, if you want to use Desmos, you can't fly around on the internet, but you can take a Chromebook, use Desmos to make your graph printed out, send it to me. Even on the hand in, if you want, you can you print it out on Desmos and figure it out that way. That's reasonable to me because it's available to anybody that can get online, right? Okay, so the first thing I want to do is, what are the standard forms of equation? Of forms, which is called the standard forms of the A. We'll do linear. Okay, that's basically a line, straight line, right? Okay, and that is going to be y equals mx plus b. Okay. Now, if we're doing it in Desmos, okay, if you have to put it in Desmos, we're going to have to put sub 1, sub 2 for points there. So we usually put in Desmos. Oops, I'm going to get the tab button to work here. There we go. In Desmos, we'll write it like this. Y sub 1, y1 equals, and that's the sub. I'm going to fix that right away. So mx1 plus b. Okay, so this would be a subscript here, down there like that. And that's how we're going to write it in Desmos when we're trying to predict what the equation of the linear line is, okay? So that's what our linear line is going to look like when we use linear lines. Now, when we get into quadratics, the standard form for a quadratic, okay, it's like I said, if you took pre-cal 20 or if you took even foundations 20, there was some quadratic stuff in there. And this is a parabola. So and what that equation is y equals ax squared plus bx plus c, just like that. Okay, and this is squared. So it's a squared term, like that. So if we do it on Desmos, we have to put the subs in there. Okay. So in Desmos, it would look like this. y1 equals a x squared 1. Oh, I don't know how to do this on both of them here. I'm going to have to draw. I'm going to have to use a marker on that one. It'll look like this. Let's move this up a little bit here so I can write better. So y1 equals ax1 squared plus bx1 plus c. Oh, darn thing. Why are you moving around on me today? Stupid thing. Come on. There we go. Okay, so that's quadratic. And then we're going to get into cubic ones, which are those shapes that, the ash kind of curvy type shapes. You can have cubic regression as well. And those ones, if you have a cubic equation, which would be C, and this one is kind of like the S two-turn shape. On the graph, okay, and those ones, we have y equals ax cubed plus bx squared plus cx plus e. Okay, so these ones, that's a cubic equation, standard form. Okay, it's basically just going down from degree, right? High degree down to low degree, putting A, B, and C and D all being numbers or integers, okay, in there, whatever they might be. Same thing with the other ones above. A, B, C, D, just some numbers. Okay. Even decimals or fractions can go in there. Whoops, 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 whoops. Not that, not that, not that. I don't have any exponent there. I'm trying to exponent to x for whatever reason. Okay, so if we do that one, and we say that this in Desmos, okay, same pattern in Desmos, you got to put the sub 1 in there. So it would look like this. y1 equals ax cubed plus bx squared with a little 1 there, and a little 1 there, plus cx with a 1 plus d. Okay, so those are the general equations that we're going to use. So the first thing I'm going to do is I'm going to just kind of do an example on Desmos with you of a linear line, and we're just going to take 5 or 6 points from a table. So I'm going to put a table up. Hopefully I've got one saved in my clipboard here, and I'm going to put it up on the blackboard, give you a few minutes to write it down. Pull up Desmos, and then we're going to do the graph and show you the steps that we take in setting up the graph, how we use Desmos to predict, and all those kinds of things. Okay, so that's pretty much, and then that's pretty much what we're going to do today. And we'll do the same thing with maybe doing a hand-drawn one as well if we have time next day or whatever. And then I'll give you some practice with that. And then we'll do the linear curve, or what happened there? Then we'll do our quadratic curves and our cubic curves next. Okay, so let's start by flipping the page ahead and hope this works. So this will be, let's get this adjusted. Maybe I'll try 18. That usually works best. And we'll say that this is an example to use, and we'll put it right here, and we'll paste it and see how it goes. Okay. The table didn't come out perfect, but I'll just adjust it here. Okay, I'm going to adjust this a little bit. So I'm just going to put some tabs in here. Number of shirts ordered, cost per item. We're going to put it kind of center it. Number of shirts ordered, cost per item. There we go. That's not bad. Maybe I should put a space. Two in there. Yeah, there we go. There, that doesn't look too bad. Okay, so this is a table that we're going to graph. So you're writing her down, I'm fixing it up. Okay, you notice I didn't go in order, I just kind of threw. I mostly went in order, and then I threw one in at the end there for whatever reason. Okay, so there's my graph. It says, then interpolate the price of a t-shirt when you have 250 shirts. Extrapolate the number of shirts when the price is $3. So we have to first say, what does interpolate mean, and what does extrapolate mean? Okay, and we're going to do best fit line. I hope this is a line, because if it's a curve, I'll be, oops, I think it's a line. Anyway. Okay, so I'm just letting you copy that down for a minute. Okay, so when we talk about the word interpolate, I'm going to put the meanings underneath, and then I'm going to pull up Desmos. So when we talk about interpolate, and when we're talking about interpolating data, we are predicting the point on a best fit line where it would be within the graph. Okay, basically is what we're doing, and that's interpolate. Extrapolate means we're predicting along the best fit line that is beyond our data point. Okay, so I'll type those ones in, but I'm just going to pause here for a sec. and I'll be right back. Okay, sorry about that. Just had to check something there. Okay, so interpolate, let's say that this is to estimate where your data point is within a point on a best fit line or curve in the graph's data. Region. Okay, and then extrapolate is the same thing except the simple change, you go outside the graph's region. Is to estimate a point on a best fit line curve outside the graph's data region. And I'm going to put that up because that's probably in the way anyway. Okay, and okay, a regression function and that's what we're going to do with Desmos here. Okay, when we're talking regression function, what is your book? Your book says a line of best fit or curve of best fit. Okay, a line or curve of best fit based on data. Okay, so what we're going to do is we're going to develop this line of best fit here today using these numbers. So let's go to Desmos, and like I said, I'm a little bit rusty, so hopefully I get it on the first crack here. So I might have to. We'll just keep that over here, and we'll just put the Desmos one over top, not that one. This one. Okay, so oops, that's the note. That's my background notes. There's Desmos. Okay, so we're looking at our table of data. Well, actually, I need my table of data, so I'm going to have to put it over there anyway, aren't I? So I can see it on my other screen. You guys can look back in your notebook. I cannot do that here, so let's just shrink this down for now, and I'll put that over here so I can see it. Okay, so the first thing we got to do is we're going to put the on the x-axis is going to be the number of shirts, and the cost per item is going to be on the y-axis. Okay, that's what we're going to do. Okay, so we got to kind of adjust our axis. So go over here into the wrench. Okay, and we don't have any negative numbers, so click on the wrench. Come on, computer. There we go. Oh, keeps on popping away. Okay, and we want to go to the x-axis, and we're going to go from the x-axis, we're going to go from 0 to 1,000, let's say. Okay, we're going to because it's asking us to extrapolate outside of the data, it says to extrapolate the number of shirts when the price would be $3. Okay, so we don't know where that might be. So I'm going to go all the way up to 1,000. Hopefully that'll be enough. We can always extend our graph anyway on Desmos, so we'll put 1,000 in there. Okay, and then for our y-axis, we're going to put the price. Now the price will start out at 0. We don't have any negative prices. And we'll go all the way to, well, we got $7.20 there for 100 items. So let's go $8, 8.0. Okay, and then we hit enter. Okay, and so you can see there's zeros down here, and let me get this wider so it covers my whole screen here. Hide this one. So zeros and then 100. And then, so what we're going to do now is we're going to put in our table of data. Okay, remember that our X points are the number of shirts and that our Y points are cost. So go over here to this add an item area, click on that, and we're going to throw a table in here. Okay, so there's a table. So X1 is 100. Y1 is 720. Okay, don't put the dollar sign in. Okay, there's our point. Okay, 300, 560. Okay, looking linear so far. 500, okay, $4, 4.00. Okay, 650, 280. The other thing I should have asked in my question is, what is the linear line of regression? We're going to figure that out, okay, as well. Okay, and 175 is 660. Okay, so there's our table of results. 1, 2, 3, 4. Did I make a mistake here somewhere? I should have 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I should have 175. Doesn't have one. Did I type that in wrong? Let me retype that in. I missed it. 175. 660. I didn't do 660. That's why. There we go. 660 in there. Okay, so there's our 5 points. It looks pretty linear. Now, the question might be to extrapolate and interpolate. So we could do that just by kind of eyeballing this, but we can make a line of best fit using Desmos here. And how we do that is we use that. If we think it's a line, we're going to put in y equals mx plus b, but we're going to use that sub 1 to represent it fits into our tables here. This is x1 and y1. And that's what we're going to type in here if we think this is linear. So what we do is we kind of go y sub 1, and then how do you get the subs on here? Well, if you go into this keyboard thing here, and you go into the next keyboard, I think it is. Okay, there's the squares, right, on the first one, and the subs are on the next keyboard here. That's the letters. That's okay. Where is the sub ones here? Maybe it's under functions. Nope. Let me pause. I'll find it here and then I'll unpause here. Like I said, I'm just a little rusty here. Okay, so let me pause for a second. Okay, turns out you just have to type 1 in. So if you go y, because you have the table there, you just go y1, it automatically subs it. Okay, then you go equals m x, okay, 1, right, plus b. Okay, I'm not sure why the b isn't working there. It should be showing me my line. It's giving me an error. Oh, the plus, I must have put a space in there. Okay. I need a 1 there. Oh. Maybe I can't use m. I'll try ax 1 plus. I'm just going to stop here. I'll just pause. I'll just figure this out, and then I'll be back here. Like I said, just a little rusty, guys. Hey, guys. Sorry, I did a little bit of research there. I forgot, you don't put an equal sign in. You put an approximation sign in. That was my mistake. So let's just kind of center this up again. Okay, so when you get to this point, I forgot. We'll have to fix that on our notes as well. So we go y1 is not equal to, but approximate. So you got to go in here and find the approximation, the kind of the squiggly one. It's above, if you look on your keyboard, it's above the tab there. It's an approximation one. It looks like, I'll see if it's on the keyboard here. It's not here. Okay, so it's this one here. I'll just use my keyboard here. That wavy line one there. Okay, that's why I wasn't getting it to work. Oops, I put it in between the 1 and the y. Just going wrong here today. So you got to put the approximation sign, not an equal sign in there. And you go mx. There we go, 1 plus b. All right, so then it graphs it here. Okay, now it's on. So the big key there is this approximation sign here, okay, and not the equal sign, okay. But and then that's this. This is the sign symbol, or the equation, pardon me, for our line. And here you can see that Desmos gives us the slope is at 0.008 and b is at 8. Okay, so if we take away this keyboard now, and we kind of zoom out a little bit, okay, there's our best fit line. And here's the equation of our best fit line. Okay, these are some statistical things that we don't have to worry about. Okay, but what we have to worry about is that the slope would be negative 0.08 and that the y-intercept b is 8. So that's where it's touching right there. Now, if we wanted to extrapolate, okay, and according to our question on here, if I bring this back over, I bring this back over, I don't know why I got 100 there. Sorry about that. If I bring this back over, they want us to interpolate the price of 250 shirts. So we got to use our line for that. So we can do that. We can print this out and do that. But 250, if we go along the line here and push our mouse down, we could slide this along the line. Okay, and so I'm going to go to 250. Okay, if we were doing it by hand, we'd have to plug it into our equation. So according to this, 250 is going to cost us $6 even, right, on the screen there. Okay, and the other one, it says extrapolate when the price is $3. So we got to get to $3. How many shirts we'd have? So we'd have to go all the way down here till we get all the way down to $3. Okay, so $3 is somewhere in here. Okay, so right there, $3 gives us, I can't hold it there because 625 shirts. So that answers our other question. Okay, and we could draw little dotted lines on the side here and insert them to do our extrapolate and interpolate as well, which we will do when we're doing it by hand. But that's how Desmos works. So the one thing is, just remember you need that approximation sign. So let's go back to our notes here. Do a little fix on that, okay? Okay, so back to our notes. We'll answer these questions here quickly in a minute. So let's go back one page on our notes. You guys do the same. Where's my mouse button? There it is. Okay, so let's take the equal sign out and put the approximation for Desmos. So let's fix that up. So go up here, take this equal out. Put the approximation sign in. I'll fix this up in both. That was my mistake. Like I said, I'm just a bit rusty, guys, using that Desmos and the graphing. Okay, so this would be that, use the approximation side when you're using Desmos to figure out what your line is. Okay, so that's what you do in Desmos when you're trying. So the next one we're going to look at is quadratics here. We're about 30 minutes in, so we're going to answer those questions, and maybe we'll do one more linear data one as well, and see if you can do it on Desmos, because there's not really, maybe do one out of the book and see how that works. Okay, so let's go back and answer our question. So now what we had here for this question is for A, when we did 250 shirts, okay, if we look at our Desmos, wrong one, sorry guys. Okay, 250 shirts. If I went here, it was $6 right there. Okay, so we can answer that. Okay, and we also know in B that $3 gave us 625 shirts. Okay, using Desmos, but the linear equation, I didn't ask this, but the linear regression equation was y equals, the m was 0. I think it was negative. Let's take a look, because it was going down, right? Right, negative because it's going down, so it's negative 0.08. Sorry, wrong one again. X plus 8, which was B. So this is our linear regression question. So if I asked you, what is the price of 250 shirts, you would take the 250, plug it into here, and you should get the same answer as we've got on the line. So let's give that a try. So if you went 250 times negative 0.008 plus 8, you should get 6, and you actually do. So it fits in with that equation. Okay, and I said, what, for $3, so if you put $3 in for the y, said $3 equals negative 0.008 x 8, so you go $3 minus 8, so you would go minus 8 on both sides, so you'd get negative 5 equals negative 0.88 x, and divide that out. And you end up getting 625 for x. So they both fit this linear regression line. Okay. Okay, so we're going to do one more together, and then that we'll call it a day. We'll call it our practice one. I won't give you any, well, maybe I'll just give you some practice ones to try on here. I wonder if they just do linear regression only, or if they do any hand ones. Okay, so the scatter plot one as well, we can do a hand example as well. So maybe what I'll do is let's do one of the ones out of the book together on this. So let me pause and I'll pick one here. quick look at it. Oh, I had it going there. Sorry, guys. I forgot to pause it. So you were bored watching me put all that in. But anyways, kind of a long video today. So anyway, hopefully you skipped ahead. So we got the lines in, and here's our line. So you see the big drop in there. So if we want to put in our best fit line, so the first question is, create a scatter plot, describe the characteristics of the data. It's pretty linear in the middle here, but at the end it kind of drops off, okay? Determine the equation of the linear regression function and the y-intercept. So that's what we do here. We go y1, the approximation sign equals mx1 plus b. Okay, and there's our best fit line according to that. So here's our slope, decimal negative 0.06517, and our y-intercept was 10.03. Okay, and that gives us the answer to that one. And interpolate the possible world record in 2007. So 2007 is 47 years after. So 47 years after, if we go here down to 47, okay, 9.72. Okay, would probably be the record there. Very, very, very close to what that point is there. Okay, or you could just plug it into the equation, and then it says, Asif Powell from Jamaica accomplished the world record time in September 2007. Research is time. Find it out. You don't have to do that. Anyway, sorry about watching me re-put the graph in there, But that's basically how linear regression works. And I will, if you want to try a couple of them on there, just using Desmos, you can, try, try like 8 and 9 there. Those will probably give you good linear regressions if you want to try a couple of plots on your own, okay, using the Desmos tool. So next day we're going to do curved lines, and then we'll talk about doing it the old-fashioned way with paper and pencil. Okay, sorry it took so long and you have to watch me redo the graph there. See you tomorrow.